103. Special sensation. Oh my gosh, how are you seeing me right now? That's my question to you. How are you seeing me right now? Sensation. What is sensation? How do we have senses? If we didn't have a brain, would we be able to see? Nope. Okay, it gets even crazier than that. It's so crazy. So here is someone smelling. That is one of your sensations, right? So this person is smelling those flowers. And here's how it all starts and ends. Receptors. Okay, so you have a receptor, some sort of receptor in your eyeball, in your nose, in your ears, on your tongue, in your skin that receive the information, right? Receive the sight, receive the sound, receive the smell, receive the taste, receive the pain on your skin, okay? That receptor sends that information to your brain. If you do not have the receptor, can you perceive? Now, let me give you an example. This is a shark, and this shark can detect electrical fields. It has receptors so that it can detect and think about receptor fields. Do you have the ability to detect receptor fields? Do you, now you see in the visual spectrum, the visual light spectrum, bees can see in ultraviolet light, the ultraviolet light spectrum. You cannot. And so what we have determined is there is very little that we actually have very little that we can perceive, that we have receptors for, that the whole world going on around us, there's a lot more out there. Take a moment to think about that. You're only getting a tiny piece of what's happening in the world. Even though your brain is trying to convince you that you know everything, you don't. You're not perceiving it at all. You can't. It starts to get weird when you start to think about that. Okay, let's start with sound first. Sound, how is sound detected? So here we have, this is a mammal ear. So whales do this, and humans do this, and dogs do this. The sound travels into this, there's literally a hole in your skull. So your ear, there's a hole, and it travels into your ear. And then you have an eardrum. You don't have to know all this, but you have an eardrum, and that eardrum beats on these little things called ossicles. And then inside here, your inner ear is where you have little receptors. And so different pitches cause different nervous system signals that go to your brain. So you have the sensation of sound. You also, in this inner ear, detect gravity. So your equilibrium is in there too. Yeah, so it also detects like equilibrium and gravity. All right. So whales have this, and humans have this, and dogs have it. Now, I just have to tell you this quick story about how you can't perceive certain things. I just want to drive this home. We used to think that elephants, back in the 70s, we didn't think elephants were very smart because they kind of waved their ears, they flapped their ears, and they made a little bit of sound, but really we didn't think they had a complex communication system. And then a person studying African elephants on the plains, the African plains, these elephant groups are far away from each other, or they used to be far away from each other. She was studying them, and she was using this tape reel to record any sounds they were making. And the tape reel broke, and she was slowly rotating it around, and she started to hear all these sounds. When she moved the tape reel slower than its normal speed. And what we found out was elephants have a complex language that is lower than what humans can hear. So the pitch of the sounds that they use for their communication is lower than what humans can hear. We didn't know. And similarly, dogs can hear pitches that are higher than us. That's why you can use a dog whistle, you can't hear it. So I want you to continue to think about, I can only perceive a little bit of what's happening in the world today, just so you know. Okay, light, what is light? Okay, light is extremely important. Most animals can detect light in some way. So even like platies, little invertebrates, they have eye spots, so they can go to the light. Why is it such a big advantage? Think about that. If you don't have eyes versus having eyes, or some sort of eye-like structure, okay, you don't have to have our eyes. What is it meant if we say that light, the ability to see light, evolved many times independently? What does that mean? So different groups of organisms, different groups of animals have very different eyes that are totally different from each other. So it happened differently for each other. Why is that an argument that sight is such a big advantage? So I want you to think about that question, because that's kind of a big deal, okay? Sight is a very big advantage. It has evolved, or you can use any word you'd like. We've adapted it many times. Different organisms have it many times, have created this, okay? Does everybody see in the visible spectrum of light? And the answer is no, right? So we talked about bumblebees, but lots of different organisms can see in different spectrums of light. What else do we want to say? Let's see what's on the next slide. Actually, that's the only slide we have for light. So photoreceptors are the receptors that receive light. You and I have things called rods and cones. I don't know if that's on here. I don't think so. I don't think you have to worry about it. Okay, no, that's fine. We have photoreceptors, but you and I can see in color. So we may be able to have photopigments or rods and cones. We have those. What would you say if I told you that birds have more cones, more different colors that they can see than we can? So we don't actually know, they're called tetrachromates, don't write it down, but we don't actually know what they can see because we can't see it, because they have extra colors. They have cones that see different colors than we do. They have ours plus extra. Why is that an advantage for birds? You can start thinking about, why might birds have the ability to see more colors? They certainly can't smell well. So very interesting. Insects, many insects have compound eyes. So they actually have their own little, they have little lenses, I'll say. They might have 2,000, you and I have one lens per eye. They might have 2,000 lenses and 2,000 little pictures of what's happening in the world. So they see the world in a completely different way than we do, and they use the ultraviolet spectrum. So how is their view different than ours? What are they seeing that we're missing? Something to remember. All right, let's talk about brains. So this is a mammal brain, this is your brain. And this is the top part of the brain, it's called the cerebrum. And so what we're gonna do is we're gonna look at different parts of the brain where thoughts take place, where sight is processed, where smell is processed, where is taste processed, where, so we'll go over each one of these that's on this list. One second, I'm gonna get rid of that. Okay, so the first question is, where does anxiety arise? And so what we're going to do is we're going to name the different lobes, and we'll put that answer into each lobe, okay? So you're going to do this too. I don't know why it's not on our, I have a feeling it's in a different, it's in a different packet, lecture packet. Okay, that's all right. We're going to go ahead and do it, and I'll fix this in our lecture notes, so it won't be a problem. Okay, so there are different lobes in the brain, and I actually think, yes, I think this slide is in the wrong spot. You already talked about this last chapter. Sorry. Okay. So just ignore all of that. I was like, what's happening? So I just need to take this out. Okay. So we were just talking about sight. Sorry about that. Now we're talking about photoreceptors. So here they are. Yay. I thought this wasn't in here. This is our eye right here. This is our eye. Light comes in this direction. We only have one lens, and light hits the back of the retina. And we have rods and cones. Cones let us see color, and rods help us see black and white. But we only see a little bit of light that's out there. Arguably the most successful, at least the most diverse phylum. Okay, so insects are so diverse and they're so amazing, and they can fly. And each one of these, imagine each one of these like little dots here, each one of these dots, that's a different kind of eye. They have kind of like their own little lens, and they all make a little picture of what's happening out there in the world. And then this beetle or this ant can take that information and make kind of a pixelated view of the world in ultraviolet. What? That's a different way. So they definitely have a different way of seeing than we do. They have their own way. They've created their own way. It's not our way, it's their way. Very cool. Okay, compare mammal and bird photoreceptors. Okay, so we're still talking about sight. Birds can see more colors than we can. Mammals can see we're called trichromates, but don't write that down, but we can see less colors than birds. What does that mean? Why, think of a hypothesis why birds and mammals see differently. Think about what we do. Think about why birds might need to see more colors. Okay, and we'll write this in the chat. We'll have a little discussion about it in the chat, but just something to think about. We always think about mammals as having everything and can see everything and can perceive everything, and the answer is no, not always the case. Okay, so rods and cones, you're going to watch a video, and what you're going to think about as you're watching this video, nocturnal means that you're out at night, you're active at night. Do they have mostly rods or cones? And then the next question would be, should humans be nocturnal or diurnal? Diurnal means that you're active during the day, based on, do we have mostly rods or cones? And you should, let me just say that your answer should be, maybe you already know about humans, your answer should be this one. Okay, so nocturnal animals would be animals like cats that tend to see well at night. Do they have mostly rods or cones? So put that in the chat. Okay, we're moving on to olfaction, smell. Olfactory receptors, we only have about 1/4 inch inside of our nose of these little receptors. What did they receive? We have like about 150, they're right up here at the top of our nose, our nasal septum. We have like 150-ish things, that's spelled wrong, that odorants that we can detect, okay, these little receptors. But guess how many dogs can detect? More than double. So dogs can smell what you and I cannot. Dogs can smell. There are certain cancers that dogs can smell. So like, that's not a myth. Turns out that dogs can detect many things because they are releasing odorants in the air. And that's actually true. They can detect things. Why? You can't, I can, because we don't have the right receptor. So there's a lot of smells out there right now you can't detect. Okay. I also wanted to throw one other thing out there because this will blow your mind. You and I can smell a teaspoon of sugar in a cup of coffee. Like if you put, or you know, whatever, a cup of tea, you can smell the coffee, the sugar. If you put it right up to your nose, you can smell it. Guess what a dog can do? A dog can smell a tablespoon of sugar in an Olympic-sized swimming pool. That's true. So dogs' sense of smell is so different, is so much stronger than ours, that they can detect. So when when somebody's dog has their head out the window and they're like, just smelling, just like life is good, they're having an experience that you will never have. I just want you to think, you will never have the experience that that dog has, ever. They're having like a movie inside their head with their nose. Think about that. All right. And then hopefully we could talk about this in class, but why is olfaction important? Turns out for humans, olfaction is not that important. For other animals that use something called pheromones. Pheromones are smells, odorants that animals of the same species can smell, and they use it for attracting mates. Humans spend a lot of money on the perfume industry. Humans have their sense of smell part of their limbic system. Humans have their sense of smell. So even though we don't have a great sense of smell, for humans, smell is emotional. Smell is emotional. For other animals, smell is not only emotional, but it's also how they attract mates. And maybe for humans too, we don't know, right? So this discussion we could talk about is, why does the perfume industry make billions of dollars a year? What are we trying to smell like, and why? And of course, this goes beyond our class, but it's just interesting to think about, like, humans as animals, what are we doing with our sense of smell? And maybe in class, if you remind me, I'll tell you about a big experiment that was done on the sweaty t-shirt experiment. I'll tell you about it in class. It has to do with how humans perceive each other through smell. Really interesting stuff. Okay, taste. Taste, where does taste occur? On your tongue. You have taste buds all over your tongue. Don't worry about the different kinds of taste buds. You do have different kinds of taste buds. Don't worry about it. These little taste buds live in these things called papilla, which just means mountain. But we're not that worried about it. We're just going to say, hey, you have somewhere around 5,000. But get this. Taste is mostly olfaction. So even though your taste buds might be working all the time, if you have a cold, you can't perceive it. Your brain needs your olfaction to be working. So if you hold your nose and eat a bunch of different flavored jelly beans, you won't be able to tell the difference between them, because your sense of smell, how your brain works, it's not the receptor, it's your brain. How your brain perceives taste requires smell. Very interesting. So that's just another piece about how important your brain is for your perception, and how important it is that you don't perceive much out there in the world. Can you perceive all that is happening in the world around you? How much of what's happening out there are you missing? Or how much out there are you perceiving in a way that's not the only way to perceive it? Like, for example, I'm seeing different colors like green and blue. What are those colors? Does this give you, I want you to stop. Does this give you a new appreciation of what it must be like to be a bumblebee flying around, seeing an ultraviolet light? What it must be like to be a dog smelling with the car window down? What it must be like to be an organism that has many, many eyes, like spiders and insects? Pretty interesting. Just think on that. It might make you feel a little humble. Hopefully you get the little sense that it's like, oh, there's a lot out there that I can't perceive. I may not be experiencing everything there is to experience. Oh, and that's it. I hope we get to talk more about it in class, because this is a great chapter.